Okay, good morning. This is Module 2, Day 2. Yesterday we did kind of an activity that helped us see the graphs of sine and cosine. Today we're going to graph sine and cosine again. And this is part 1. So the first thing we want to do, if you printed off the worksheet from Canvas, is we're going to graph sine and cosine here. So over here in the table we're going to put our angles, pi over 6, pi over 4, pi over 3, and so forth. So I'm going to fill those in, and okay, so there's not a whole lot of room here, but I went ahead and filled in the table, and now we're going to plot the points, and then we'll finish them based on patterns. So at 0, 0, there is a point. Then at pi over 6, we're at 1/2, so let's call this 1 and this -1. Okay. At pi over 6, we're at positive 1/2. Then at pi over 4, we are at square root of 2 over 2, which is approximately 0.7. And this one's approximately 0.87. So maybe about there, and then here, and then pi over 2 is at 1, positive 1. 2 pi over 3 is the square root of 3 over 2, which is about 0.87. Then we're back to 0.7, then we're back to 1/2, then a 0, negative 1/2, negative 0.7, negative 0.87, negative 1, 0.87, negative 0.7, negative 1/2, and then back to 0. And so here is the sine curve. I thought green would show up a little bit better, but it did not. Okay, so one thing to talk about is that the angles here, I can continue in both directions because it doesn't matter how many times I go forward in the circle or backwards. I can go to whatever angle I want. I can go all the positives to infinity, and I can go all the negative angles to negative infinity. So my domain for this function is going to be negative infinity to positive infinity, or all real values, all real angles. The range here is actually finite. So my minimum is -1 and my maximum is 1. Okay. The rhythm here, so here at the bottom it talks about the rhythm. And the rhythm is basically, how is this graph moving? So we start here at what's called a 0. Then we go to a maximum. Then we go back to a 0. Then we go to a minimum. And then we go back to a 0. And so that's the way this function is moving. Well, this represents one complete cycle. We started at 0 and we went all the way around the circle to 2 pi. One complete cycle. So we started at 0, 0. Our maximum is actually right here. This is our max. It is going to be at pi over 2 and 1. Our minimum is right here. That is going to be at 3 pi over 2 and -1. My zeros are where it crosses the x-axis, and so that would be at 0, 0. That would be at pi and 0, and that would be at 2 pi and 0. And we will end at 2 pi and 0 for one complete cycle. That's where we end, right here. Okay, so we start at 0, 0, then we go to a max, we go to a 0, then we go to a min, and then we stop at 2 pi. That completes one cycle for sine. All right, we use this equation, y equals sine of x, where remember, x is going to be an angle. So when it refers to this x, it is referring to the angle that we are putting into that function. Okay, we're going to do the same thing here for cosine. We're going to go through and graph it. So at 0 and 1, so we're going to put this to be 1 and this to be -1. And we'll actually start right there. At pi over 6, we're going to go square root of 3 over 2, and then pi over 4, square root of 2 over 2, pi over 3 is 1/2, pi over 2 is 0. And then we continue our graphs. We actually did all of these yesterday. So if you wanted to look back at our activity and table from yesterday, it's the same points. So at pi over 6, we're at like 0.87. Remember, that's 0.87, and this is 0.7, and then 1/2, and then 0 at pi over 2. And at 2 pi over 3, we're at -1/2. Then we're at -0.7, -0.87, -1 at pi. And it's like we just it's kind of like graphing parabolas. There's always that symmetric point. Okay, and then we go back. Okay, so our critical points here are our maximums, our minimums, our zeros. And so our graph looks like this. Okay. All right, so the rhythm here, the rhythm is going to be max, 0, minimum, 0, max. Okay, we're going to start at 0, 1. We start at a maximum, which is 0, 1. And our minimum occurs at pi and -1. Our zeros are going to be pi over 2 and 0, and 3 pi over 2 and 0. And we will end at 2 pi and 1. 2 pi and 1. This function is y equals the cosine of x. And remember, x here represents an angle that we are inputting into this function. Okay, both of these graphs here represent one cycle of the wave. It referred to a bug going around the circle. So if the bug continues to go around this circle in a negative direction, then the cycle would repeat infinitely, either in the negative or the positive. Okay, and sine and cosine waves are generated from a repetitive motion, to keep that in mind. The t-value for this represents the distance traveled, but it can also be time it took to complete a cycle. So when we start talking about functions here, we might see them represented in different ways, as distance or as time. Okay, so that's conclusion of part 1.